students, welcome to our YouTube channel Experience Tutor. Today we'll discuss Class 11th Physics, Laws of Motion, Chapter 5, NCRT Solution, Part 4. Our mission is to provide free classes on YouTube for all the students of Class 6 to Class 12 and the students who are preparing for IIT, JEE, NEET, NDA and other competitive examinations. Before we begin, we have a small request. Please subscribe, like, and share our channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin the lesson. In the last class, we have done till question 5.30. Today we'll start with 5.31 exercise questions. A train runs along a unbanked circular track of radius 30 meter at a speed of 54 km per hour. The mass of the train is 10 to the power 6 kg. What provides the centripetal force required for this purpose? The engine or the rail? What is the angle of the banking requires to prevent wearing out the rail? Now let us see the solution. So here the radius of the circular track is r is equal to 30 meter. Now speed of the train v is equal to 54 kilometer per hour, which is equal to 15 meter per second. Mass of the train m is equal to 10 to the power 6 kg. The centripetal force is provided by the lateral thrust of the rail on the wheel. As per Newton's third law of motion, the wheel exerts an equal and opposite force on the rail. The reaction force is responsible for the wear and wear of the rail. The angle of banking theta is related to the radius r and the speed by relation. Tan theta is equal to v square upon rg. Putting the value of v, r and g, we get 15 square upon 30 into 10 is equal to 225 upon 300. Theta is equal to tan inverse 0.75, that is 36.87 degree. Therefore, angle of banking is about 36.87 degree. Now let us move to the next question. Now, the next question is 5.32. A block of mass 25 kg is raised by a 50 kg man in two different ways as shown in figure 5.19. So this figure, what is the action on the floor by the man in the two cases? If the floor yields to a normal force of 700 Newton, which mode would the man adopt to lift the block without the floor yielding? Now let us see the solution here. So 5.32, 750 Newton and 250 Newton in the respective cases. This is the answer. But how we got it, here we have explained. Mass of the block and method is B. Method is B. So this is the answer, but how we got it, we are now explaining. Mass of the block M is equal to 25 kg. Mass of the man capital M is equal to 50 kg. Acceleration due to gravity 10 meter per second square. Force applied on the block F is equal to 25 into 10, that is 250 Newton. Weight of the man W is equal to 50 into 10, that is 500 Newton. Case 1. When the man lifts the block directly, in this case the man applies a force upward direction. This increases the apparent weight. And action on the floor by the man is 250 plus 500, that is 750 Newton. Case B. When the man lifts a block using a pulley. In this case, the man applies a force in the downward direction. This decreases his apparent weight. So, action on the floor by the man is equal to 500 minus 250, that is 250 Newton. If the floor can yield to a normal force of 700 Newton, then the man should adopt the second method to easily lift the block by applying lesser force. And this is the solution. Now let us move to the next question. The next question is 5.33. A monkey of mass 40 kg climbs on a rope, figure 5.20, which can stand a maximum tension of 600 Newton. In which of the following cases will the rope break? The monkey A climbs up with an acceleration of 6 meter per second square. B climbs down with an acceleration of 4 meter per second square. C climbs up with a uniform speed of 5 meter per second. D falls down the rope nearly freely under gravity. Ignore the mass of the rope. Now let us see the solution. So we have discussed the solution in different cases. Case A. In the first case, mass of the monkey M, that is 40 kg. Acceleration due to gravity G is equal to 10 meter per second square. Maximum tension that the rope can bear, that is T max, is equal to 600 Newton. Acceleration in acceleration of the monkey A is equal to 6 meter per second square upward. Using the Newton's second law of motion, we can write the equation of motion as T minus mg is equal to ma. T is equal to mg plus a is equal to 40 10 plus 6, that is 640 Newton. Since T is greater than T max, the rope will break in this case. Case B. Acceleration of the monkey A is equal to 4 meter per second square downward. Using Newton's second law of motion, we can write the equation of motion as mg minus t is equal to ma, that is t is equal to mg minus a, and putting the value of m, g and a, we get 40 bracket 10 minus 4, that is 240 Newton. Since t is smaller than t max, the rope will not break in this case. Case C. The monkey is climbing with a uniform speed of 5 meters per second. Therefore, so uniform speed is 5 meters per second. Therefore, acceleration is 0. That is A is equal to 0. Using Newton's second law of motion, we can write the equation of motion as T minus mg is equal to ma. Since A is equal to 0, then uh, ma is equal to 0. Therefore, T is equal to mg. That is putting the value of m and g, that is 40 and 10, we get 400 Newton. Since T is smaller than T max, the rope will not break in this case. Case D. When the monkey falls freely under gravity, its acceleration will become equal to the acceleration due to gravity, that is A will be equal to g. Using Newton's second law of motion, we can write the equation of motion as mg minus t is equal to mg. That is T is equal to mg minus z in bracket, that is 0. Therefore, T is less than T max. The rope will not break in this case. So this is, we have checked all the 4 cases and we have discussed when the rope will break and when the rope will not break. Let us move to the next question. Now let us do question number 5.34. Two bodies A and B of masses 5 kg and 10 kg con is in contact with each other. Rest on the table against a rigid wall, shown in figure 5.21. So this is the figure. The coefficient of friction between the bodies and the table is 0.15. The force of 200 Newton is applied horizontally to A. What are A, the reaction of the partition, B, the action reaction force between A and B, what happens when the wall is removed, does the answer does the answer to B changes when the bodies are in motion? Ignore the difference between mu s and mu k. Mass of a body A is equal to ma 5 kg. Mass of a body B is equal to mb 10 kg. Applied force F is equal to 200 Newton. Coefficient of friction mu s is equal to 0.15. The force of friction is given by the relation Fs is equal to mu ma plus mb g. Putting the values of mu ma and mb and g, we get 0.15 bracket 5 plus 10 into 10. Upon solving, we get 1.5 into 15, that is 22.5 Newton leftward. Net force acting on the partition is equal to 200 minus 22.5, that is 177.5 Newton rightward. So as per Newton's third law of motion, the reaction force of the partition will be in the direction opposite to the net applied force. Hence, the reaction of the partition will be 177.5 Newton in the leftward direction. Force of friction on mass A is equal to Fa mu ma g. Putting the value of mu ma and g, 0.15 into 5 into 10, that is 7.5 Newton leftward. So the net force exerted by mass A on mass B is equal to 200 minus 7.5, that is, so one correction was there, it is 192.5 Newton right word. Now, now as per Newton's third law of motion, an equal amount of reaction force will exerted by the mass B on mass A, that is 192.5 Newton acting leftward. When wall is removed, the two bodies will move in the direction of the applied force. Net force acting on the moving system will be equal to 177.5 Newton. The equation of motion for same for the system of acceleration A1 can be written as net force is equal to ma plus mb into A. A is equal to net force upon ma plus mb. Putting the values of net force and ma and mb, we found 177.5 upon 5 plus 10, that is 15, that is 177.5 upon 15, that is 11.83 meter per second square. Net force causing mass A to move, Fa is equal to ma into A, which is putting the value of ma and A, we get 5 into 11.83 is equal to 59.15 Newton. So net force exerted by mass m on mass A on mass B is equal to 192.5 minus 59.15, 33.35 Newton. That is equal to 133.35 Newton. More correctly, 133.35 Newton. The force will act in the direction of motion as per Newton's third law of motion. An equal amount of force will exerted by mass B on mass A, that is 133.3 Newton acting opposite to the direction of the motion. And this is the solution. Now let us see the question number 5.35. So a block of mass 15 kg is placed on a long trolley. The coefficient of static friction between the block and the pulley is 0.18. The trolley accelerates from rest with 0.5 meter per second square for 20 seconds and then move with uniform velocity. Discuss the motion of the block as viewed by a stationary observer on the ground, B, and stationary an observer moving with the trolley. And let us see the solution. Mass of the block m is equal to 15 kg. Coefficient of static friction, that is mu, is equal to 0.18. Exertion of the trolley A is equal to 0.5 meter per second square. As per Newton's second law of motion, the force F on the block caused by the motion of the trolley is given by the relation F is equal to ma, putting the value of m and a 15 and zero point 0.5, we get 7.5 Newton. The force is acted in the direction of the motion of the trolley. Force of static friction between the block and the trolley F is equal to mu mg, putting the value of mu m and g 0.18 into 10 into 15 into 10, that is 27 Newton. The force of static friction between the block and the trolley is greater than the applied external force. Hence, for an observer on the ground, the block will appear to be at rest. When trolley moves with uniform velocity, there will be no applied external force. Only the force of friction will act on the block in this situation. An observer moving with the trolley has some acceleration. This is the case of non-inertial frame of reference. The friction force acting on the trolley backward is opposite to the pseudo force of the same magnitude. However, this force acts in the opposite direction. Thus, the trolley will appear to be rest for the observer moving with the trolley. And this is the end of this solution. Let us move to the next question. Next question will solve, that is question number 5.36. The rear side of the truck is open and a box of 40 kg mass is placed 5 meter away from the open end as shown in the figure 5.22. The coefficient of friction between the box and the surface below it is 0.15. On a straight road, the truck starts from rest and accelerates with 2 meter per second square. At what distance from the starting point does the box fall off the truck, ignoring the size of the box? So mass of the box m is equal to 40 kg, coefficient of friction mu is equal to 0.15, initial velocity u is equal to 0, acceleration a is equal to 2 meter per second square. Distance of the box from the end of the truck s dash is equal to 5 meter. As per Newton's second law of motion, the force on the box caused by accelerated motion of the truck is given by F is equal to ma. So putting the value of m and a, we get 40 into 2, that is 80 Newton. As per Newton's third law of motion, a reaction force of 80 Newton is acting on the box in the backward direction. The backward motion of the box is opposed by the force F friction. F acting between the box and the floor of the truck. This force is given by F is equal to mu mg. Putting the value of mu, m and g, 0.15 into 40 into 10, we get 60 Newton. Net force acting on the block, that is F net is equal to 80 minus 60, that is 20 Newton backward. Now, the backward acceleration produced by the box is given by A back is equal to F net upon m, that is 20 upon 40, that is 0.5 meter per second square. Using the second equation of motion, time t will be calculated as s dash ut plus half at square. Instead of putting the value of s dash u t a and a, we get 5 is equal to 0 plus half 0.5 into t square, that is t is equal to root 20. Hence the box full will fall from the truck after root 20 seconds from the start. The distance s traveled by the truck in root 20 second is given by the relation s is equal to ut plus half at square, u is equal to 0, therefore 0 plus half putting the value of a and t, we get 2 into root 2 20 square, that is 20 meter. And this is the solution. Now let us see the next question. The next question is 5.37. A disk revolves with a speed of 33 1 upon 3 revolution per minute and has a radius of 15 meter. Two coins are placed at 4 centimeter and 14 centimeter away from the center of the record. If the coefficient of friction between the coins and the record is 0.15, which of the coin will revolve with the record? So let us see the solution part. Coin placed at 4 centimeter after the center. Mass of each coin is m. Radius of disk is 15 centimeter, that is 0.15 meter. Frequency of revolution nu is equal to 33 1 upon 3 revolution per minute, that is 100 upon 3 upon 60 revolution per second, that is 5 upon 9 revolution per second. Coefficient of friction mu is equal to 0.15. In the given situation, the coin having a force of friction greater than or equal to the centripetal force provided by the rotation of the disk will revolve with the disk. If this is not the case, then coin will slip from the disk. Coin placed at 4 centimeter, radius of revolution r dash is equal to 4 centimeter, that is 0.04 meter, is equal to 2 into 10, 22 upon 7 into 5 upon 9 is equal to 3.49 per second. Angular frequency omega is equal to 2 pi nu, that is 2 into 22 upon 7 into 5 upon 9, that is 3.49 per second. Frictional force F is equal to mu mg, which is equal to 0.15 into into 10, which is equal to 1.5 Newton meter. Centripetal force of the coin F centripetal is equal to m r dash omega square. Putting the value of omega and r dash, we get m into 0.04 into 3.49 whole square. Now, upon solving, we get 0.49 meter Newton. If F is greater than F centripetal, the coin will revolve along with record. Coin placed at 14 centimeter, radius r double dash is equal to 14 centimeter, is equal to 0.14 meter. Angular frequency omega 3.49 per second. Friction force F is equal to 1.5 meter Newton. Centripetal force is given by F centripetal is equal to m r dash omega square, r double dash omega square. Since F is greater than F centripetal, the coin will revolve with the record coin placed at 14 centimeter. Radius r double dash is equal to 14 centimeter, that is 0.14 meter. Angular frequency omega is equal to 3.49 per second. Friction force F is equal to 1.5 meter Newton. Centripetal force is given by F centripetal m r double dash omega square m into 0.14 into 3 into 10 to the 3.49 square, that is 1.7 meter Newton. Since F is less than F centripetal, the coin will slip from the surface of the reward record. And this is the end of the solution. Let us move to the next question. The next question is 5.38. You may have seen in a circus a motorcyclist driving in vertical loops inside a death well. Explain clearly why the motorcyclist does not drop down when he is in the uppermost point with no support from below. What is the minimum speed required at the uppermost position to perform the vertical loop if the radius of the chamber is 25 meter? Let us see the solution. 5.38. In a death well, a motorcyclist does not fall at the top point of a vehicle of a vertical loop because both the force of normal reaction and the weight of the motorcyclist act downward and are balanced by the centripetal force. The same is shown in the figure. The net force acting on the motorcyclist is the sum of the normal force Fn and the force due to gravity Fg is equal to mg. The equation of motion for the centripetal acceleration AC can be written as F net is equal to MAC Fn plus Fg is equal to MAC Fn plus mg is equal to mv square by r. Normal reaction is provided by the speed of the motorcycle at the minimum speed v min Fn is equal to 0, that is mg is equal to mb square min upon 2. Therefore, v min is equal to root rg, that is root 25 into 10 is equal to 15.8 meter per second. Let us move to the next question. 5.39. A 70 kg man stands in contact against the inner wall of a hollow cylinder drum of radius 3 meter rotating about the vertical axis with 200 revolutions per minute. The coefficient of friction between the wall and his clothing is 0.15. What is the minimum rotation speed of the cylinder to enable the man to remain stuck to the wall without falling when the floor is suddenly removed? Now, the solution is mass of the man is m is equal to 70 kg. Radius of the drum r is equal to 3 meter. Coefficient of friction mu is equal to 0.15. Frequency of rotation mu is equal to 200 revolution per minute. That means 200 upon 60, that is 10 upon 3 revolution per second. The necessary centripetal force required for the rotation of the man is provided by the normal force Fn. When the force when the floor revolves, the man sticks to the wall of drum. Hence, the weight of the man mg acting downward in is balanced by the friction force F is equal to mu Fn acting upward. Hence, the man will not fall until F mg is greater than mg and less than mu fn. Therefore, which is equal to mu m r omega square g is less than mu r omega square. Therefore, omega square is greater than under root g mu r. The minimum angular speed is given by w main is equal to under root g mu r. To find out the value of omega min is equal to we just need to put the value of g mu and r, that is under root 10 upon 0.15 into 3, that is 4.71 radian per second. Let us see the next sum. Now 5.40, the last sum of this exercise. A thin circular loop of radius r rotates about its vertical diameter with an angular frequency omega, so that the small bead on the wire loop remains at its lowermost point for omega less than equal to under root g upon r, where angle made by the radius vector joining the center to the bead with the vertical downward direction for omega is equal to under root 2g upon r. Neglect friction. So let us see the solutioning. 5.40 solution. Let the radius of vector joining the bead with the center makes an angle theta with the vertically downward direction. So this angle, we are talking about this theta. So OP is equal to R is equal to radius of the circle. R and N is normal reaction. The respective vertical and horizontal equation of for focus can be written as mg is equal to n cos theta. Ml omega square is equal to n sin theta. This is equation 2. First one is equation 1 and this is equation 2. Now in triangle OPQ we have sin theta is equal to L by R. L is equal to R sin theta, that is equation number 3. Substituting equation 3 in equation 2, we get m R sin theta omega square is equal to n sin theta. M R omega square is equal to n, that is equation number 4. Substituting equation 4 in equation 1, we get mg is equal to n r omega square cos theta. Cos theta is equal to g by r omega square. This is equation number 5. Since cos theta is less than equal to 1, the bread will remain in the bead will remain in the lowermost point for g upon r omega square less than 1. That is for omega is less than equal to under root gr. So we can write omega is equal to under root 2g upon r, or omega square is equal to 2g upon r, equation number 4. The equating equation on equating equation 5 and 6, we get 2g upon r is equal to g upon r cos theta. Therefore, therefore cos theta is equal to half theta is equal to cos inverse zero point 0.5, that is 60 degree. And this is the end of today's class and this chapter 5, laws of motion. Please subscribe, share and like our channel. Please Click on the subscribe button to support us and click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you for watching Experience Tutor.